Hello friends, welcome back to another video on this channel. In today's video, I will show you a Python based QR code sorting system. So basically it consists of this robot arm which is connected to an Arduino Uno. The Arduino Uno is connected to the computer using the cable there. The computer is running a Python program which uses my phone as a webcam. So it's using simple droid cam to read a bunch of QR codes which are printed on a piece of paper here. This piece each QR code has the data which is present in a text file which has a respective number from 1 to 3, and these three numbers represents location. So location 1, 2 and 3 respectively. The Python program reads the QR code. It can then query it through the file and detect which location is to be placed. It writes that using serial to the Arduino, and the Arduino then moves the arm using the stepper motors and the servos to the required location. Let me show you it's working. So first of all, I will take my phone here, which is the camera which is running the system. I will point it towards a QR code. Say I point it towards box 2 QR code. I move the light a little bit towards it. As you can see, the arm starts moving and it is moving the arm to the location 2. So box 2 stands for location 2. As you can see, it put the servo. So the arm moving down represents putting something down. So this is because of lack of proper equipment, this doesn't exactly pick or place something, but it is just a proof of concept. Now I will show you location number 1. So if I point it towards box 5 QR code, which is location number 1, as you can see here, data only is 1. So it puts it here, which is much less than location 2. Now if I point it towards one more QR code, which would be location 3, as you can see, when I point it towards box 6, you can see the data only is 3. So it takes it and puts it towards much farther away location, which is box 3. Location 3. Now the way this is connected is actually really simple. So I have an LCD here, which is an extra piece, but this was just for texting. So basically it's just a simple connect up a stepper motor, connect up the servos to the Arduino, normally how you would connect it, everything. So in my case, I believe my stepper motors are connected. All of the Arduinos, the stepper motors, the servos are connected to digital pins. So I will show the code as well as the Python program now. Yeah, I will switch over to the computer to show the code and the Python program now. Okay, I have switched over to the computer now. As you can see, I am running the Python program which is connected to my phone. So this is just the camera. If I stop this Python program, you can see the simple working of it. So if I get rid of the run, you can see the Python program now. So first of all, we start by importing libraries. So this just requires 2 libraries. So serial library is usually always there. So I'm using PyCharm, by the way. I highly recommend you use this too instead of the normal Python IDE, as it has several inbuilt libraries, and installing libraries are also very easy. You can just do it from here. So other than that, you are going to need OpenCV for the camera, as well as you are going to need the PyBar library for reading the barcodes. Then this is the place where you would want to change something. So this is the Arduino Uno's COM port, or any Arduino in fact you can use. So you can fire up device manager by going here. You can open up device manager, and you can see here in ports, you will see the Arduino port. So this is your Arduino COM port. So just for example, mine is running on COM 5. So as you can see here, I have written COM 5 over here, and this is just your baud rate, so 9600. This is then the Arduino code, which I will show shortly. Next, here we are just seeing the barcode, and we are drawing the rectangle over it, as you saw in the image, the green rectangle. And then this is where the barcode is being decoded. So it takes the type of the barcode as well as the data. It then takes the data, which is this is for the variable for data, which is being decoded from the barcode. Then it sets it as a variable a. Then it makes the variable a string, and it sets that to the output as a variable output. Now it will open the file which I mentioned before. So this is a file which is present in the directory of the which is supposed to be put into the same directory as the Python program. So this is the simple.txt file. This file contains the barcode. So these are the datas of each of the barcodes, and this is the respective location. So 1, 2, 3. So it queries it through this file, and then if it finds the output in a file, it will print string found, and then it will print the line number as well as the line. Then what it does, it will replace the line where there is the output. So basically the data from the barcode is being replaced, which in this case, so if I fire up the file again, if you notice here, it has box 1 written and 1. So for example, if I show it box 3 QR code, it reads box 3 here. Then once it finds this, it will remove box 3 part of it, and it will print, it will put this as a space. So empty, as you can see here, it shows box outputs this as nothing or a space, and then it will print out box 3 on to the data only, as well as this, it will serial write the data. This is the data which is received by the Arduino, and then here is just returning the image, and here this is just for showing the frame, like the preview of the camera. Now this is something you might want to change. So this is your the camera. So for look, by default, if you have only one camera, it will be 0. However, if you have multiple cameras, this will go up, so 1 2 3 and so forth. So you might want to change this if you need to, if your required camera doesn't show up. Now this is the code which is running on the Arduino. Out of here, the liquid crystal, this screen part of it is not necessarily required. This is just for testing. This shows the location which is present on it. So I have this installed for testing. Now you are going to initialize the servos. There are, ideally there was 3 servos. However, I could not get the third servo to power up because I kind of overloaded it, because I used a very small servo for this bigger arm. So I ended up just leaving it as is and just running off of 2 servos. So here you are setting the steps per revolution for your stepper motor. So I'm using a BY28J. So this is my steps per revolution. Although this is not necessarily required here, this is how, if you want to do a full revolution, then only this is needed. However, it is there, so you can, like, if you want to change the location, which I'll show you, have to use this to some extent. I'll tell more about that later. Now here we are just setting the constant integer for the LCD, and here we are just initializing that, and here we are initializing the stepper. These are the pins for the stepper, 8 9 10 and 11. You can change those as well. Now here we are just setting flag 1, flag 2 and flag 3 as boolean, so yes or no commands. Now in boid setup, we are just beginning the LCD, printing hello, and then we are just attaching all the servos and writing the default starting position as well as starting serial here. Now this is where the real work is done for the Arduino. So the cursor is set to 0 0, and if serial is available, we will see set integer C to serial read. Now when 49 is sent to the serial, 49 in Arduino IDE stands for 1 for Python. So when 49 is sent, that is 1 is pressed, the flag 1 is set to true and the rest are set to false. So this is basically location 1, location 2 and location 3. If flag 1 is set to true, the system does the location 1. If true is set to true, then location 2, and 3 for 3. So 49, that is 1, is for location 1. 50, that is 2, is for location 2, and 51 3 for location 3. So as you can see, it says the other 2 as false and the respective flag to true. Now this, if flag 1 is set to true, then you are going to stop the serial first, because you already have received it. And what it does, if you do not stop the serial, is it will keep piling it up. So if it reads the location 10 times, it will actually move it 10 times before doing anything else. So we are just ending the serial. So once it's read, it will not continue to pile it, it will not have to pile it up, and it won't be backlogged. Then we are going to set flag 1 to false. Otherwise, if we do not do this command, the system keeps repeating as well. Then we'll just write it on LCD, and then we are setting the servos to locations, delays, and then again and again and again. So you might want to change all of these based on trial and error, whether basically where you want to put it. Now you are also changing the stepper motor's location. So you are going to do this by changing this value. Negative means anti-clockwise and positive means clockwise in my case. So first it moves clockwise, then it moves anti-clockwise in the same number of steps to bring it back to the original location, and then it will clear the LCD at last and start the serial. Same for location 2 as well as 3. So you can change all the values on all of these to make the arm go as you wish based on your application. And here we are just having one final delay so that the system doesn't crash, because the Arduinos cannot handle this much data incoming as the Python can, because it's obviously running on a main computer and this is just the microcontroller. So with that, that is the code. I will have both the Python code as well as the Arduino code linked down below. All you have to do is download the files, install these two libraries here, and then you can just simply run it. Run the Python code, first upload the Arduino code to the Arduino, then check your COM. You can also see them here if you are using a genuine board. It'll show you right there, COM5. Place that here. If you want to change your display capture, video capture input, you can change that there, and you can just run the Python program and show the camera the system, and it will move it to the respective location. I hope you guys enjoyed this video. If you did, please be sure to leave a like on this video and subscribe to the channel. And yeah, I'll see you guys next time.